Hello friend, welcome to Dr. Subhash Technical Campus, Junagadh. Myself, Professor C.B. Bamrulia, and today's our video topic is two transistor model of SCR, and this topic is covered in power electronic subject. So let's begin. Now, first of all, what is two transistor model of SCR? In this model, we have to discuss about two transistor. Means, first of all, what is transistor? Transistor is a three terminal, three layer, two junction solid state electronic device. And two type of transistor is NPN transistor and PNP transistor. Means, according to the material, semiconductor material, we can design a two transistor model. Now, the two transistor analogy of SCR is a method of representing of SCR as a combination of an NPN and PNP transistor. Means, using two transistor, we have to construct one SCR. In this model, we have to discuss different two transistor and current and voltage characteristic of this. Now, SCR is a three terminal device, means name of three terminal is anode, cathode and gate, and the structure of SCR is made up of PN structure, means four layer. We have to use here four different type of semiconductor slab and connect each other and make a total number of three junction J1, junction J2 and junction J3. According to the junction condition, means according to forward or reverse condition of the junction, we have to discuss or we have to achieve the different VI characteristic of SCR. In the VI characteristic of SCR, there is a four different part or four different layer. The first layer is known as reverse breakover or reverse blocking mode. Then second region is forward blocking mode. And the third region is conduction mode that we have to discuss in last slide. Now here the construction of SCR is given. In construction there is a anode, cathode and lower terminal is gate. The total number of four layer PN is there, and in this layer we design the three junction J1, J2 and junction J3. Here this is the basic construction design of SCR. Now, in this tutorial, we have to discuss this T1 and T2. Means two transistor we have to use. T1 is a PNP transistor and T2 is a, this transistor is a PNP and this transistor is a NPN. Total two transistor is there, and according to this conduction and blocking of this transistor, the current is different. So, here in the symbol we can see that here T1 is a PNP transistor because arrow is inside the transistor, so it is known as PNP transistor. And here the arrow is outside the transistor, so this is the NPN transistor. Now in transistor the terminal name is, this is the emitter, base and collector. Here the whole circuit known as SCR, so the SCR terminal name is anode, cathode and gate. So in this slide we will discuss about total number of layer, total number of terminal, so we can design the SCR circuit. So this one is about two transistor model of SCR. Now let me discuss about internal structure of SCR. Now in previous slide we have discussed about this anode, cathode and anode, gate and cathode. According to this gate terminal or gate's current, the conduction of anode to cathode is different. Now the current flowing from anode to cathode is totally depend upon this gate terminal. Whenever we apply some gate current, then it trigger, then anode current will flow from anode to cathode. Now junction J1, junction J2 and J3 is forward or reverse. Whenever it in forward bias, at that time the depletion region width is very narrower and it allow to pass current. Means whenever any junction is in reverse bias mode, at that time the width of depletion region is wider. and due to this wider width, the current does not pass from this junction, and it totally work as a insulator. So this is the characteristic of SCR. Now we have in this video we have to discuss about how to design a SCR using two transistor. So here junction J1, here junction in between this P and this 2N is connected, means N of the N region of T1 or Q1 and N region of Q2 is directly connected with each other, and it make a layer or N layer, and this J2 is in between this P type N type material and this P type material of Q1 and P type material of Q2 is directly connected each other. But here you have to remember this P type material and this N type material is not connected each other, means the Q1 Q2 this P region of Q1 and is not connected with Q2, and this N region of Q2 is not connected with Q1. Only these two region is connected each other and make a junction J1, J2 and J3. Here current is the anode current or total anode current is also known as thyristor current. So total current or thyristor current is IT, and the current flow from gate is known as IG, gate current, and the current at cathode terminal is known as IK, means total cathode current. So here the total three type of current is available: IT, IG and IK. Now what is this current about? Let me discuss about this. Now this circuit is already we have discussed in the previous slide. Now in symbolic form, when we apply symbol to this PNP transistor and NPN transistor is like this. Now here IA, anode current, is totally equal to the thyristor current. Now in this transistor, this is emitter terminal, this emitter, this is collector, and this is the base. Now base of Q1 is connected to collector, this one is base and this is the emitter. So base of transistor 1 is directly connected to collector of transistor 2, and this gate terminal and this collector terminal is directly connected to the base of transistor 2. Here emitter is not connected to second. Now in this figure we can discuss about current. Now what is IB1, means base current 1 is equal to the collector current 2, means this terminal is collector. So collector terminal of Q2 is equal to the base current of Q1. Here also IC1 and this is the IB2. IB2 is nothing but, according to the Kirchhoff current law, these two current is added each other and make a IB2. IB2 is equal to IG plus IC1, and IK cathode current is nothing but is addition of this IB1 plus IB2. IB1 means IC2 and IB2. Whenever we add these two current, it make a IK, means total cathode current. So in equation form, here alpha 1 and alpha 2, this is the current gain of transistor 1 and this is the current gain of transistor 2, means total the gain of this SCR or this figure is mixing of alpha 1 and alpha 2. So anode, gate and cathode, according to this terminal name, we have to design our current characteristic of this two transistor model. Now in general transistor equation, we already know about IC is equal to beta IB plus 1 plus beta ICBO. This equation is from general equation of transistor. Whenever we want to find the collector current, and collector current is totally depend upon beta value. Beta IB plus 1 plus beta ICBO. ICBO is nothing but collector current when base is open, means it is a reverse conduction mode. In reverse, due to the minority charge carrier, this ICBO current is flow whenever transistor is in off state. So this equation is directly taken from the transistor general equation, and IC, so we can say that IC is equal to, this equation is in terms of beta and this equation is in terms of alpha. So IC is equal to alpha IE plus ICBO. here you have to remember these two equation, and it is taken from directly general transistor equation. So this equation is very basic equation for the transistor. E is equal to IC plus IB. According to the Kirchhoff current law, IC and IB, whenever we add these two current, then it make IE. So the total current or maximum current of transistor is IE. IE is nothing but addition of IC plus IB. IB is in terms of microampere and IC is in terms of milliampere. So the total current IE is in terms of milliampere. Always you have to always remember IB is always in microampere, means minimum current or very fewer current is required to flow the IB. So IB is in microampere and IE and IC is in milliampere. Now IB is equal to IE 1 minus alpha minus ICBO. Now this equation is IB equation, and IB equation current base current equation is IE 1 minus alpha minus ICBO. This is also the general equation of transistor. So friends, you have to remember this equation for the transistor. Now let me start with two transistors. The first transistor is consider the PNP transistor, and the equation is like, first of all we have to identify the IE1, IC and alpha. Here IE1 is equal to IA because anode current is totally the emitter 1 current, and IC is equal to IC1 and alpha is equal to alpha 1. We have to write using this figure. In figure we can say that we can see that the IE1 is equal to IA, IC is equal to IC1 and alpha is equal to alpha 1, and ICBO is equal to ICBO1 and IB is equal to IB1 with directly. Now put this value in previous equation IB. The IB1 is equal to IA 1 minus alpha minus ICBO1. This all value we have to put in previous equation, so we can get the IB1. Now let's consider the NPN transistor. Now in NPN transistor, the IC is equal to IC2, IB is equal to IB2, IE2 is equal to IK. Cathode current is nothing but emitter 2 current, means the second transistor emitter current is IK, and IK is equal to the addition of IA plus IG, means anode current plus gate current is totally cathode current, and IC2 is equal to alpha 2 IK plus ICBO. That we have to put this value, this all value we have to put in previous equation. So we can directly say that IC2 is equal to alpha 2 IA plus IG, because IK cathode current is nothing but IA plus IG plus ICBO2. So this is the equation number 2. When we put this all value in this equation, then we will get the IC2. Now equation number 1 and equation number 2 we have get. Now from the equation equivalent circuit, we see that IC2 is equal to IB1. Now here IC2, the collector of transistor 2, means this terminal is directly connected to base of transistor 1, so this terminal. So this equation is right here from the here we can say that IB1 is equal to IC2, so IC2 is equal to IB1. So IA is equal to alpha 2 IG plus ICBO1 plus ICBO2 1 minus alpha 1 plus alpha 2. This is the simplification form of IA. In previous slide we have seen the equation of IA and put all value, then we will get this total equation. IA is equal to this ratio. This ratio is nothing but it is the in terms of alpha, and alpha IG alpha 2 IG plus ICBO1 plus ICBO2 divided by 1 minus alpha plus beta, alpha 1 plus alpha 2. So this equation is we get from the equivalent circuit. And now let's take case 1 and case 2. Now case 1 is nothing but whenever the gate terminal is open. Now if this gate terminal is open, means there is no any gate current. Whenever we have not give any triggering to the SCR, then case 1 is achieved. IG is equal to 0. At that time only reverse current or minority charge carrier current is flow, so it is related to the ICBO. So ICBO 1 plus ICBO 2 divided by 1 minus alpha 1 plus alpha 2, this anode current is only due to the minority charge carrier, means SCR is in blocking mode, so it is not allowed to flow the anode current. So we can say that Ig is equal to 0 is in terms of blocking mode. Now case 2, whenever we give some gate current, means it not equal to 0, at that time Ia is equal to alpha 2 Ig, then ICBO 1 plus ICBO 2 divided by 1 minus alpha 1 plus alpha 2. Here only difference is that we have to consider the Ig, means here Ig is not equal to 0, so the some value of Ig. Now in this equation, whenever Ig is equal to 0, means this term becomes 0, so we will get directly this equation. But whenever Ig is not equal to 0, then we have to consider alpha 2 into Ig. So total equation is like this. Ia is case 2 equation is not equal to Ig is not equal to 0, then Ia is like this. So we have to understand these two equation and from the equivalent circuit. Now this is the VI characteristic. Basic idea about the SCR we already discussed in previous video about the VI characteristic of SCR, but here you have to revise something about the SCR. This is the construction model of SCR. Anode, cathode and gate. Here P N structure is there. Junction junction 0, junction 1 and junction 2. In some figure here J1, J2, J3 is given. It total no problem. Whenever J1, J2, J3 is given, or total number of 3 junction is there. Now using 2 transistor model, this is the PNP transistor and lower one is NPN transistor. Whenever we connect this 2N and this 2P, then we will design a total SCR or 4 layer structure. So we can say that this is structure 1, structure 2, 3 and 4. This 4 layer device is SCR. Now this is the VI characteristic of SCR. Now previously we have discussed this region is known as reverse blocking mode and this region is known as forward blocking mode, and this is the conduction mode. Means in this region SCR is in off state, here also is in off state, but whenever we apply some gate trigger or apply some higher voltage, then SCR become on and it is in conduction, forward conduction mode. So we can say that SCR is only operate in forward conduction mode. Here VBO is most important voltage. Without any gate pulse, SCR become on, it known as VBO. Means whenever gate terminal is open, whenever we have not apply any voltage to the gate, and further we increase the voltage and SCR become on, so it is known as maximum forward blocking voltage is VBO. After VBO, SCR become on. Now in this figure we can see that whenever we apply some gate current Ig1, here Ig is equal to 0, means we have not apply any gate current, but if we apply some voltage current to the gate, then Ig1 current, then Ig2, then Ig3, then if we increase the current from current to the gate, then SCR become on earlier. Now minimum current required to SCR become on is known as latching current. After latching current, SCR become off, and whenever our current, anode current, it become below the holding current and SCR become off. So holding current is related to turn off the SCR and latching current is related to turn on the SCR. So you have to remember these two, holding and latching current of SCR. Now here we get V1 greater than V2 greater than V3, means whenever voltage is applied higher than the previous, then SCR become on. Here also the Ig current, Ig3 is higher than the Ig0 or Ig1, means SCR blocking region is reduced using this gate current. So whenever we apply higher gate current and SCR become faster on. Whenever we apply lower gate current or 0, then SCR become on slightly late from the previous one. Now This is the construction using the transistor model. Whenever we add two transistors, then P region is totally separate out, T1 and T2. N region is also separate, and this N type material and this P type material is connected each other and make a junction J1, J2 and J3. The current from anode is IA, current from IG is equal to current from gate is equal to IG, and current from cathode is equal to IK. So we can discuss or we can separate out this SCR in two transistor. So here in this video you have to remember this latching current, holding current, reverse blocking mode, forward blocking mode, and forward conducting mode. Here dotted line is indicate the gate trigger. Triggering is nothing but whenever we apply some current to the gate terminal, it known as triggering of SCR, means start condition of the SCR. It faster whenever gate current is higher, is slower whenever gate current is lower. So friends, this one is about two transistor model of SCR. You have to remember this concept for the SCR design and construction of SCR. So you can take a screenshot and you can draw this figure in your notebook, so you remember for the exam purpose or competitive exam purpose. So friends, this one is about true transistor model of SCR. If you have any question or doubt, then feel free to write on chetanb@drsubhastech.edu.in, so you understand this topic very well. Okay, thank you.